Good morning, everybody. This is going to be our lesson for September 30th. This is basically the lesson you would have gotten on Wednesday. I'm filming it on Wednesday, but you guys will have access to it on Thursday, okay? So a couple of announcements before we get started with the lesson. Two things. One is, I guess you probably can't see all the way over there, but basically the project for the year, or for the quarter, that football stats project, we're going to have it due basically at the end of the quarter. I'll probably put it in Skyward a little bit before, so that way you'll know whether or not it's in. Then you can let me know if you're having problems or whatever, and we can talk about it. Okay, so the project will be due at the end of the quarter, which is basically 2 weeks from now. So if you haven't gotten on it, make sure you get on it really soon here. Okay. And then the second thing is, if you haven't taken the first test yet, please reach out to me. I think most people have, but if you haven't taken the first test, you'll need to probably come pick it up from the school. You can take it home, work on it there, bring it back, and go from there. Okay. So what today's lesson is going to be, we're going to continue with what we talked about on Monday. Okay, and so speaking of Monday, if you guys weren't here, so I know we had some students missing from each class. This is the homework assignment that we did on Monday, okay? It's pretty easy to get through. And so if you didn't get that done, again, you're either gonna need to come by and pick one up here, or there's gonna be a little link in the assignment where you're watching this video where you can download it and work on it. You can download it, print it off, and bring it in, and I'll grade it like that, okay? So there's a couple different ways you can go about it, but we'll get started with the lesson for today. Okay, so again, we're doing the same 5-step process that we learned last time, where we're coming up with our hypotheses. We're coming up with a way to sort of compare the data, which is we're going to talk about here. We're going to come up with a test statistic. We're going to use the dot plot with our test statistic, and then we're going to draw a conclusion based on all of that information. Okay, so there's also going to be a link. I'm going to put it in a few different places for chapter 2. Okay, I just scan the book in so you guys all have access to it. We're going to start here on, right there, you can see at the top, page 52, everybody, okay? So page 52. And this example has to do with the 2009 Major League Baseball playoffs. The manager for the Yankees, Joe Girardi, made headlines by choosing a poor hitting backup catcher, because they basically thought that the pitcher was going to throw better. The pitcher performed better for the Yankees with this guy versus this guy, okay? So we're basically going to go through the same process that we've gone through for the last week to figure out, to get our test statistic, to draw conclusions and all this business, okay? So you can follow along with the book right here, or you can just kind of listen with the video. We're going to go over all this. So what we're testing here is the manager's reasoning was that the pitcher seemed to pitch better with Molina catching rather than Posada, okay? So basically we're saying that the pitcher did better with this guy. So in other words, the opponent batting average, okay, that's what we kind of care about. The opponents did worse with the pitcher. So this is kind of like a backwards example, but we'll get to everything as we go here, okay? So to measure the performance, again, we're going to use opponent's batting average. So opponents were batting 0.270 against AJ Burnett when Jorge Posada was catching, okay? So 0.270 when Posada was catching. This is the normal guy, okay? This was the normal starter. Okay, so we'll bring this. Opponent's batting average was 0.27, so we're going to be a little bit above here. Okay, and you can see this in the book. I've flipped these over a little bit, so in the book, Posada's on the left and Molina's on the right. I decided to flip it just so it all kind of lines up with what we're seeing here. Okay, so this was Posada. How the other teams basically did when Posada was the one that was the catcher. Okay, so then on the flip side, we're going to talk about when Molina was the catcher. Okay, so the batting average when Molina was the catcher, we're probably going to need to actually calculate that on our own real quick. Okay, so again, this number, this 0.270, this basically just came from doing 103 divided by 279, okay? I do 103, whoops, not 279. That was a mistake. So 103 divided by the total, okay? 103 over 382. So I do 103 over 382, okay? And that's where we get basically 0.269 right there, okay? Which is, we round that up to 0.27. So to find the same statistic with Molina, the other guy, we're gonna take the batting average, which again is hits divided by total. So 56 divided by 253, okay? And we're going to get about 0.221, okay? So 56 over 253, 0.221. So we can fill that in right here. Okay, so 0.221 is going to be slightly lower. So right off the bat, there is definitely an argument to be made that The pitcher for the Yankees here did better, and what I mean by did better is the opponent had a worse batting average with this guy than they did with this guy, okay? So let's keep going with the problem here. We've created the graphical display to compare the performances, right? That's what we did. This graph is basically what you see right there. Okay, so the first step in our process, the one that we laid out, was basically to come up with our hypotheses that we're going to use, okay? So the hypothesis that we're interested in testing, the null hypothesis always has to do with no change in ability, right? Any deviation from performance just has to do with a change in random chance, like that kind of realm. So the null hypothesis here is going to be the pitcher, AJ Burnett, had the same ability when Molina was catching and when Posada was catching. So basically our null hypothesis here is going to be the pitcher, okay, we don't really care about what his name is necessarily, the pitcher had the same ability with Molina as he did with Posada. So the pitcher had the same ability with Molina and Posada. Okay, and again, what this is saying is that like any deviation in performance, we're just saying with this null hypothesis that that deviation is just due to random chance, okay? So now our alternative hypothesis, HA, we'll put it down a little lower. Our alternative hypothesis is going to be that the pitcher had a greater ability when Molina was the catcher than when Posada was the catcher, okay? So the pitcher had a greater ability when Molina was the catcher. Okay, so we're going to go ahead and test this. So we need to come up, so this was step one, right? We come up with our hypothesis. So we sort of did it in reverse order from what the book did. We come up with our hypothesis first, and then that's when we like to start looking at the data, is after we've come up with our hypothesis. And then step three is going to be finding our test statistic, you guys, okay? So the test statistic that we're going to need to use here is going to be the proportion of hits with Posada catching minus the proportion of hits with Molina catching, okay? So our test statistic, delta, we'll call it change in batting average. How about that? Delta BA, okay? So test statistic is going to be delta BA, change in batting average. Okay, and this is basically going to be, let's just double check that one more time. This is going to be the proportion of hits with Posada catching. So basically the batting average with Posada catching minus the batting average with Molina catching, okay? So BA, so it'll be BA Posada, okay? BAP minus BA Molina, okay? And we already have those calculated, right? We got, we'll write them down right here. So the batting average with Molina was a little lower, right? That was about 0.221. And the batting average with Posada was about 0.270. Okay? So we can just plug those in right here. All right, we're going to do 0.270 minus 0.221. And we're going to get 0.049. Let's just double check that in the calculator. 0.270 minus 0.221. Yep, we get 0.049. Okay, that's our change in batting average. 0.049. Okay, this is our test statistic right here. Okay, 0.049 is our test statistic. Okay. So there's another little section here that talks about coming up with like a simulation. Okay, we already talked about that in class, and the simulations, like for the most part, when we do these, like when I have you guys do them, we're going to do them using technology. We're not just going to be doing them with like flashcards and stuff like that. We might go over a couple examples like that in the future, but we're not going to really be doing that much, so I'll skip that section. So we're right on to the dot plot here. Okay, so 100 trials of the simulation were conducted, assuming that the ability of the pitcher was the same with both catchers. The results of the simulation are shown. I've got them right here, okay? So again, this is really important where we define like what came first with the subtraction? We decided to do Posada minus Molina. Okay, so it's important to note that that's what this is right here. This is Posada minus Molina. Okay. So the results are shown in the dot plot, which is up here on the board. Okay, so to find our p-value, okay, which is kind of the next step, we're going to count how many dots are at or above our test statistic, right? Okay, so 0.49. That's basically going to include these dots here. Okay, so right here. 0.49 is basically right here below 0.50. It's going to include all these dots. So we got to count up those dots and divide by the total number of dots, which is 100. Okay, so I count these up. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we get 11 out of 100, which is basically 0.11, right? And this is our p-value. That's why we do that. It's our p-value. Okay, 0.11 is our p-value. So right off the bat, based on that p-value, we should know, right? We should kind of know what realm we're dealing with. Are we in the realm of saying that this is no longer valid? Well, the realm of saying that the null hypothesis is no longer valid has to do with p-values that are less than or equal to, or actually just less than 0.05. So because our p-value is 0.11, our conclusion is going to be that we cannot reject the null hypothesis. It was likely due to random chance, okay? So that's the last little bit here, is we conclude, and I've just got space for it right here, so I'm going to put my conclusion here. Okay, conclusion, our p-value equals 0.11, which is greater than 0.05. Okay, it's greater than or equal to 0.05. So we cannot reject the null hypothesis. Okay, so the difference in performances was likely due to random chance. That's what we're getting at here, okay? So difference in performances due to random chance. And a lot of the time I just abbreviate random chance RC. RC, random chance, okay? So that's it for this first example. We're gonna do one more here. We're about 12 minutes in, which is fine. I wanted this video to be about 20 minutes, so we're good. The next example we're gonna do is gonna be in the practice problems section of the book. So if you're following along with the PDF like you should be, flip to page, let's see. We're gonna be on page 62 right here, and we're gonna do example 11, okay? So 62, example 11 starts at the bottom here. This has to do with the San Antonio Spurs in 2009 and 2010, okay? So we're gonna be using this dot plot. I think you can see it from the camera angle I've got going on here. Yeah, a little bit. Let's see if we can rotate a little. Hopefully I don't knock everything over. I've got to like jerry-rig the stand up here to get everything. Okay, perfect. All right, so I'm going to erase what's on the board here on the right just so that we can have some room for the next example. Okay, and if that first example was a little confusing, you can always just like go back and rewind, rewatch. Following along with the book is probably going to be your best bet because it sort of lays everything out. I know some of you guys maybe you don't want to have to read through a textbook, but at the end of the day, that's going to be your best resource for learning all this stuff, as well as watching these videos, okay? So this, question number 11, the 2009-2010 San Antonio Spurs, did they have a greater ability to win at home versus on the road? Okay, so at home, they won 70.7% of their games. So this is interesting. We're not using a two-way table right here. They're just telling us right off the bat at home. So their winning percentage at home, so winning percentage H equals, it looks like that was 70.7, okay? So basically they win about 7 out of every 10 games at home. Okay, their winning percentage on the road is 51.2%. So their winning percentage on the road was 51.2%. Okay, 51.2%. Okay. So 100 trials of the simulation were conducted, assuming that their ability does not change. And the dot plot is provided there on the left. Again, it's in the book, and I've also drawn it up there on the left, okay, on the board up there. So question A is asking what information is provided by the dot plot. And again, this is 100 simulations where they basically take these winning percentages and they just plug them into like a simulator. Okay, we've talked about ways we can do simulations where we could just have flashcards with, you know, the number of games they won this year, the number of games they lost, and we just randomly assign them to home versus away games. That's kind of how you do a simulation, okay? So part B is to estimate the p-value, okay? Part C is to interpret the p-value, and part D is based on the p-value, draw an appropriate conclusion, okay? So really, we're just gonna go through the process that we've talked about to answer these questions, okay? So the first thing, because in order to draw a conclusion, we need our hypotheses that we're gonna be testing. Okay, so our null hypothesis here is always no change in ability, right? So our null hypothesis is basically the Spurs had the same ability to win at home versus on the road, okay? So the Spurs had the same ability to win at home and on the road. Okay, so then our alternative hypothesis, again, we're wondering whether or not they are a better home team, like whether or not their ability to play increases at home for whatever reason, okay? So the Spurs have a greater ability to win games at home. Let's just make it simple. The Spurs have a greater ability to win games at home. Versus when they're on the road, okay? So part A, what information is provided by the dot plot? We already talked about that, okay? I'm not too concerned with you guys. I mean, as long as you know it, you know it. If you don't know it, then we can talk about it a little bit more, but this is something that a lot of kids kind of struggle to get early on, and then as we kind of get along with the semester, it starts to make more sense, okay? So we'll keep going with that idea throughout the whole year. Part B, estimate the p-value, okay? So to estimate the p-value, the first thing we need is a test statistic. So the important thing is that this is the simulated difference in winning percentage, and we're doing basically winning percentage at home minus winning percentage on the road, okay? So our test statistic, I'm kind of abbreviating there, we're gonna say delta, so change in winning percentage, okay? Delta WP. Okay, change in winning percentage, and this is going to be winning percentage at home minus winning percentage on the road, okay? We'll get a little separation here. Okay, so let me just double check, make sure. Okay, we can see that just fine. So winning percentage at home minus winning percentage on the road. Okay, so again, it's important to note that each of these dots was basically winning percentage at home minus winning percentage on the road for each simulation, okay? So for our test statistic, we're gonna do 70.7 minus 51.2. Okay, we do that in our calculator real quick. 70.7 minus 51.2, and I get 19.5, okay? 19.5%. So that's our test statistic. So now in order to get a p-value, we take our test statistic of 19.5 and we bring it over here. Now notice, you guys, that these numbers are all whole numbers, they're percentages, okay? So in the book, sometimes we've dealt with numbers that are like decimals. Like for our example that we did originally, it was decimals, okay? But this is gonna be in percentages. So we're looking at 19.5 or higher, okay? Because of the way we phrase this question. So 19.5, let me just double check, make sure. I kind of wrote the graph, I was a little bit off with it, but it was mostly good. So it looks like we've got, if we were talking about 19.5, in the book, it has a couple dots that are basically about right here. So I screwed up just a little bit. But we've got 2 dots right at 19.5 and then 1 dot way above, okay? So we have 3 dots that are at or above our test statistic. 19.5 would be about right here, 1, 2, 3, okay? So we do 3 divided by 100. Okay, 3 dots at or above 19.5 divided by 100 total dots for the total number of simulations, and this gives us 0.03, which would be our p-value, okay? So there we go, we just estimated a p-value with the information that we had. That was part B. Now part C is to interpret the p-value, okay? So interpreting the p-value, we're just taking the p-value and we're applying the results of what we get with our p-value to which hypothesis we're going to support. What is that evidence of, okay? So again, another thing that we went over a ton so far this week and last week was basically understanding that when you have a p-value greater than or equal to 0.05, this is support for the null hypothesis. This supports H naught as being likely true, okay? If we have a p-value less than 0.05, this supports the alternative hypothesis, okay? So again, we're just looking at what our p-value is, 0.03. Which category does it fall into? Is it above 0.05 or is it below? Well, in our case, it's below, right? Okay, so because our p-value, so our conclusion here, our interpretation of the p-value really, okay, our interpretation of the p-value, so this kind of answers C and D at the same time, is that because it's low, we have a low p-value, so p-value equals 0.03, which is less than 0.05, so we can reject the null hypothesis, right? So that's kind of how we prove, that's how we like establish evidence for the alternative, is we say p-value is 0.03, which is less than 0.05, which means that we can now reject the null hypothesis. So we reject H naught, and we have convincing evidence that HA is likely true, okay? And that's it. Okay, this is the process that we're basically doing all year with p-values, with hypothesis testing, with coming up with test statistics, using dot plots, and all that business, okay? So that's it for the 2 examples I had today. If you want to do like your NFL picks, go ahead and like just circle the games and send them in to me. We'll keep that going. I'll do mine and we'll talk about that in the next video, who I pick. And that's basically it, you guys. Thanks for watching, and I'll see you in the next video.